Today we're going to be looking at the third step for determining limits algebraically. In our previous videos, we talked about the first two steps you would try. So the first step would be to just plug in the value x is approaching, and we saw that worked some of the time. And then when we ran into our first issue, we learned about our second step we could always try. So if you try to plug in your value and you end up with an undefined answer, the second step I would always recommend trying is to factor or one out the problem term. And so in this example, we tried to plug in 2, we got 0 over 0, so then we were able to factor out GCF from the top expression, and then you were able to cross off or cancel those terms and actually find your limit that way. However, sometimes you're still going to run into tricky limits that look like this. And so we'll try these examples and kind of talk about how to figure out your answer from here. So in this problem, we have the limit of 6 over x squared as x approaches 0. So the very first thing you always try, of course, is to plug in that what x is approaching. So 6 divided by 0 squared is still 6 over 0, which is undefined. And so then we try to move on to our next step, which would be factoring, and there's nothing to factor here. There's no GCF I could pull out of the top and the bottom. And so then now we're kind of stuck. So let's go ahead and graph example 9 in our calculator and see if we can't figure out what the limit is using our graph. So if we go to your y equals screen, I'll plug in 6 divided by x squared, and then I always hit zoom 6 to get a standard graph window. Okay, so now we can kind of see what our graph of 6 over x squared looks like. So what y value is the function approaching when we get close and close to x equals 0? Well, we would say that from the left and the right hand side that it's approaching, it's going up for forever, so we would say infinity. So you can say the limit as x approaches 0 of 6 over x squared equals infinity. And then it says now do the same thing with example 10, but this time examine where x equals 3, because you'll notice that in this example as well, if we try to plug in 3 right off the bat, we end up with 3 minus 5 over 3 minus 3. We end up with negative 2 over 0, which is still undefined, and we still can't factor anything from it. And so now let's go ahead and we'll try to use our graphing calculator to figure out this one as well. So on top in parentheses, we'll have x minus 5, and then in the denominator, x minus 3. And again, I'll hit zoom 6 to get me to a standard window. And we're looking as x approaches 3. So we're looking at this value right here. Well, this one from the left-hand side, it looks like my graph is going up forever. But from the right-hand side, it looks like it's going down forever. And so if I was going to write the general limit over here, well, what would my general limit be? If my left-hand limit and my right-hand limit don't match, then my general limit is D and E. Now, it's very nice that we have a graphing calculator to be able to determine these ones, but we have to be able to do these even if we don't have a calculator in front of us. And so I'm going to kind of give you the tools for how to do this calculation without looking at a graphing calculator. So let's go ahead and go down here. Whenever we end up with a rational expression where the denominator is equal to 0 and the numerator is some number, so think of some number over 0, which is what we ended up having up here, right? 6 over 0 and negative 2 over 0. When we try to plug in a, the limit of that function will either be labeled infinity, negative infinity, or D and E for does not exist. Very important point here. Technically, all three of these answers fall underneath the does not exist category because infinity and negative infinity aren't actual numbers, but we want to be as precise as possible. So even though these technically all do not exist because they're not actual numbers, we still should be able to say whether it's infinity, negative infinity, or if they don't match, okay? So to decide which of the three answers is correct, we test the left and right hand limits of the function, because that's what we needed to do over here, right? We needed to see whether the left and right hand limits match. And to do that, we're going to pick numbers that are very, very, very close to 0 from the left and the right, and we're going to plug them in here. But you don't care about what your actual numerical answer is. You only care about what the sign of your answer is. So for example, if I am looking at, and this is the kind of shorthand I use, so I'll do x approaching 0 from the left-hand side. So if I pick a number that's slightly less than 0, that would end up being 6 over some tiny negative number squared. And so you'd end up with 6 over a negative number squared is a positive. And so then my answer for my left-hand limit would be positive infinity. It's very, very general. Like, you're not getting precise specific numbers here, but because we know already that our answer falls into one of these categories, we just have to see whether it falls into infinity or negative infinity, and then whether if those match or not. So then let's look at the right-hand limit. So x approaching the right-hand limit. So if I picked a number very close to 0, but from the right-hand side, well, that would be a positive number squared. And so then I'd still end up with 6 over a positive number. So my right-hand limit would also be infinity, which means my general limit overall would be infinity. Okay, we're going to do a couple more examples of these ones because they're a little difficult. All right, so now let's look at x approaching 3. So in this problem, if I am plugging in a number very, very close to 3, but a little bit less than 3, I'd end up with, on top, I'd have a number close to 3, but less than 3 would be a negative on top, because you'd have, like, for example, 2.99999 minus 5 would still give me a negative number because 2.9 is smaller than 5. And then on the bottom, I'd end up with 2.9999 minus 3, which would also be a negative number. And so then a negative divided by a negative is a positive. So that would give me infinity. But then let's look at a number very close to 3, but slightly greater than 3 on top. So that'd be like 3.1, for example, or 3.0001. 3.0001 minus 5 would still be a negative number. And then on the bottom, 3.001 minus 3 would be a positive number now. And so a negative divided by a positive would be negative, which means my right-hand limit would be negative infinity, which means because my left-hand limit and right-hand limit don't match, you get D and E. And hopefully you'll notice that these were the two problems we started off with, and they match, right? So from our graph, we figured out that this was positive infinity, and from our algebra now you can figure out, or excuse me, from my arithmetic, I figured out that example 10 was D and E as well. So you can do these by picking numbers and just paying attention to the signs. And this only works when you can't plug in and you can't factor anymore, okay? So let's go ahead and we'll try example 11. So in example 11, I want to double check first. I already double checked with these ones that when I plug in these numbers on their own, I get 0 over 0, or excuse me, a number over 0 before I try any of this stuff. So that's the first thing, like I said, you always want to do. And I definitely will try to catch you in it with practice problems and stuff. So make sure that the first thing you're always doing is just testing to see, oops, that's supposed to be a plus, whether or not your number or your limit is actually undefined to begin with. Okay, so let's see, on top we got 4 plus 12 plus 8, so it's 16 plus 8, so we got 24 on top. And then on the bottom, I have 4 minus 12 plus 8, so 4 and 8 is 12, minus 12 is 0, okay. All right, and so then the next thing that you always want to try is you want to try to factor if possible. Oh, I might run out of room here. Double check. All right, so on top, let's see if we can factor that at all. What multiplies to 8 and adds to 6? That would be a 4 and a 2. X plus 4 and x plus 2. And then the same thing would happen on the bottom, except for they'd both be negative. X minus 4 and x minus 2. Okay, so I tried to plug in, I got an undefined answer. I tried to factor, and I did factor, but I can't cancel anything out. And so now my only option is to now go back and try my left hand and right hand limits like this. So let me do that in a different color so we can kind of see what we're going with. So now if I'm thinking about plugging in, and one thing is when we're doing this part now, because I already have a factored form, the factored form is actually easier to use. So if I'm choosing numbers that are slightly less than 2 and I'm plugging them into this equation, that's the same thing as plugging them in over here as well. And this is a little easier to see whether or not your answers would be positive or negative, regardless of what the actual numerical answers would be. So for example, if I plug in like 1.99999, this first factor would still be positive. And so with the second factor, right? So you'd have a positive number times a positive number. Oops. Over, now if I plug in 1.999 down here, I'd have a negative number and then another negative number. Oops, there we go. And so then I end up with positive times a positive, positive times a positive over a negative times a negative. So you'd end up with positive over positive, which would give me infinity. And then let's see down here, x approaching 2 from the right-hand side. So if I plug in like 2.0001, positive number, negative number, positive, positive, negative. And then 2.001 minus 2 here would be positive, so that's where the change is going to occur. So overall, you'd have a positive over a negative, which would be negative infinity. So the actual limit of this equation is D and E because your left-hand limit and your right-hand limit don't match. All right, I'm running out of room over here, but let's go ahead and we'll start it, and I can draw wherever I need to. So in this problem, when I have a -4, I'm going to go ahead and plug that in first and foremost just to double check everything. So -4 cubed plus -4 squared minus 16 times -4 minus 16 all over -4 squared plus 16. And this one, I might have to use my handy dandy calculator for that one. Or you can try and do it in your head too. Nothing wrong with that. I just want to make sure my video ends up correct. Minus 16 times -4 and then minus 16. So on the top, we get 0, which is not very exciting. And on the bottom, you get, well, -4 squared is 16. 16 plus 16 is 32. Oh, so overall, the answer to this one is automatically 0. Be careful, because like we've done a couple that are this example, so you're going to want to keep doing that same example, but you have to go through all the steps first, right? Double check that you can't plug in this number first. Double check that you can't factor and cancel anything out. All right, well, that is this section of the notes. So we've got one more coming up. I know this seems long, but I'd rather give you all of the information and break it up into chunks than try to do it all at once. So, all right, let me know if you have any questions.